Hello guys, for this new video we are going to continue studying the tangent lines that can touch in a specific quadratic function. So with the previous concepts we saw of taking and calculating how much the slope is for a specific point, we are going to do something else now. This is the next topic you're going to see, and it's named equation of the tangent and normal lines. So it's still a very simple topic and very easy to do, but you have to take in consideration more concepts than the previous topic. So until here we already all know that curves can have specific points where a line can pass through, and these lines are called tangent lines, right? Tangent lines. Now, this tangent line touches the parabola in one specific point. So the new concept we're going to learn here is that this specific point is going to be named as point of contact. Now, this point of contact, we know it has a specific x and y. So we also know that if you know the function of this parabola, you can obtain the slope by taking the derivative of this function, and you can obtain the specific slope for this specific point of contact, right? That's what we saw in the last topic. Now, the other thing that you're going to know is this line, this tangent line, this one in I think it's orange, in color orange. This line has also a specific function. What do I mean? You have to remember that lines are line equations, something like this. Y minus y is equals to m times x minus x1. So using this formula or this form of the line equation, you can obtain the function or the specific line equation for this tangent, and that's what we are going to do in this topic. We are going to obtain the tangent equation of these lines, okay, in the specific points. So it's going to be really easy. Also, that's this part, the equation of the tangent lines. Now, what about normal lines? Because also in the topic it says normal lines. The normal lines we are also going to calculate it, and they are a little bit more difficult than the tangent lines, but I think that's still simple. The only thing we are going to do is that we have to remember what is a normal line. So a normal line is going to be a line that goes perpendicular to the tangent line. So exactly in the middle. So let's say this is the middle of the tangent line here. And if we do or we cross a perpendicular line, this perpendicular line in blue, I'm going to do something like this, is going to be called the normal. So tangent lines are lines that touches the quadratic function in one point, and normal lines are going to be those that are perpendicular to the tangent line in a specific point. Okay, so this is going to be a normal line. Now, we also have to calculate the function of this normal line using the same principle, this one. So let's see an example, maybe it's going to be clear for you. Here I have an example that says, determine the equation of the line to the curve fx equals to x squared minus 4x plus 5 when x is equal to 1. then it says obtain the equation of the normal. Now, what do we have to do? First of all, we have to identify the quadratic function. We already have it over here, so I'm going to write it again. I'm going to put it here. Fx equals x squared minus 4x plus 5. Now, what elements do we have to know in order to complete the line equation? So let me put here the line equation. The line equation is going to be y minus y1 equals to m times x minus x1. Remember, these ones, this x and this y, are going to be constant, so we cannot move or replace them. The values that we are going to replace are these ones, the y1 and the x1. So how do we obtain y1 and x1, and how do we obtain also this one, the slope? So it's going to be, we're going to require, I think are like 2 or 3 steps. First of all, we are going to obtain x and y. This x1 and y1. x1 is going to be this one. The problem already gives it to you. So here I'm going to put the next step, and it's going to be that x is equals to 1. Now, how do I calculate y1? The only thing you have to do is you have to substitute this value here, okay? Because fx is also, you can rewrite like this: y it's equal to, I'm going to put it 1 squared minus 4 times 1 plus 5. Okay? Remember that fx also means y. That's why I put it like right here. So 1 to the square is going to be 1. Minus 4 times 1 is going to be minus 4. So we're going to put 1 minus 4 plus 5. So 1 minus 4 is going to be minus 3 plus 5 is 2. So up to here we have that y is equals to 2. So the complete coordinate is going to be 1, 2. Okay? That's the first step. Until here, I think it's pretty easy to obtain. Okay? But if you have questions, this is a good moment to start writing it and ask me your questions on our session we have in video. So make sure you understand all up to here. So the next step is that I'll have to change the piece of paper. Well, I'm going to retake the coordinate. It's going to be 1, 2, right? Now, the next step is that we need to calculate the slope, because we don't know it. We already know how much is x1 and y1, but we need the slope. How do we calculate the slope? Remember the last topic. That's what we do. All the topic. We were calculating the slope of tangent lines in a specific point. So we have here the specific point, and we have the quadratic function that is x squared minus 4x plus 5. So the next thing you have to do is you have to calculate the derivative of this function. You remember we have to obtain the derivative, because if we derivate this function, we are going to obtain the slope, the function of the slope. So let's do it right here. Derivative of x squared is going to be 2x, then minus 4x is going to be 4, right? Minus 4. And this one you can cancel it, right? So the slope is 2x minus 4. And how much does x, but it is the value of x. So the value of x, you already know it. We already have it here. It's 1. So we have to substitute the value of x. It's going to be 2 times 1 minus 4. And that's going to be 2 times 1 is 2, minus 4 is minus 2. So up to here, we already have the value of x1, the value of y1, and the value of the slope. I'm going to rewrite it right here. So x1 is equals to 1, y1 is equals to 2, and the slope is equals to minus 2. The last step you have to do is you will have to replace these elements in the line equation, like in line equation in the point slope form. Yeah, I was forgetting about this. This is called the point slope. If you remember math, I think it was in third semester. Yeah, right? Yeah, well, this is the point slope form of a line equation. So you the only thing you have to do, you have to replace the values here. So I'm going to do that, and I think it's going to be something like this. It's going to be y minus y1. So y1 is 2. So it's y minus 2. That's equal to the slope, that is going to be minus 2 also. Remember, this minus 2 came from this minus. Okay? That's why it's minus 2. Don't get confused. The value of y1 is 2, positive. But we have this minus here. So this 2 is going to be converted to minus 2. So the slope is minus 2. And here, you don't have to change the sign because you don't have anything. So the real value of m is going to be minus 2. So then x, that stays the same, and minus x1, minus, and x1 is 1. So you have here the line equation. The only thing you have to do here is to simplify this equation. How do you simplify this equation? Well, it's really easy. You have to multiply this and pass this minus 2 to the other side. It's going to be something like this. Minus 2 times x is minus 2x. Minus 2 times minus 1 is plus 2. And this minus 2 is going to pass to the other way, like plus 2 also, because you have a minus sign, so it's going to be a plus. And the last step is going to simplify more, because 2 plus 2 is 4. You're going to obtain minus 2x plus 4. Okay? So this is going to be the equation of the tangent line. Okay? And I think this was really pretty easy. Now, this is the first part, because the whole problem sets determine the equation of the line to the function x squared minus 4x plus 5 when x is 1. And also at the end it says obtain the equation of the normal. So to obtain the equation of the normal, you have to remember, let me put this on the side, a previous concept you have that says if you have a line in a plane, a Cartesian plane, like this one, and you have a perpendicular, let's say this line has a slope of, I don't know, 3, and you have a perpendicular line exact in the middle of this line. If this line is perpendicular to this line, to this line, the perpendicular, I want to mark it with another color. This is the perpendicular. And the straight line is this one, okay? So if this line is perpendicular to this one, the slopes have to be inverse reciprocal. I don't know if you remember how to do that, but let me show you. If the tangent line has a slope of 3 and the normal is a perpendicular line in the middle, so the slope of the normal has to be reciprocal and inverse. What's that? Reciprocal means that you have to change the sign of the number. So if you have 3, we're going to change it to -3. And inverse means that you have to put it like a fraction. So you have 3, you have to put it down, and up in the fraction, in the numerator you have to put number 1. So let's say we have a slope of 3/4, and you want to obtain the inverse reciprocal. You only have to swipe or to swap the numbers and change the sign. Okay, that's inverse reciprocal. Also, if you have here, I don't know, let's say -2, and you want to obtain the inverse reciprocal, the only thing you have to do is to replace the values or to swap them and to change the sign. It's 1/2. Okay? Well, let's make another example just to be sure. Let's say we have a -1/4 and we want to obtain the inverse reciprocal. Have to swap these values. 4/1 is 4, and change the sign. So that's why it's positive. Okay? Well, with the previous problem with this one, we already have the slope, and the slope is going to be -2, right? This one, -2. So for obtaining the equation of the normal, we are going to take that -2. So the slope is going to be -2. This is the slope of the tangent line. How do we obtain the slope of the normal? Well, we already said that if it's a perpendicular line, we have to obtain the inverse reciprocal. So the inverse reciprocal is going to be 1/2. This is going to be the slope of the normal line. Then, how do we obtain the equation of the normal line? It's going to be the same procedure as we do it with the tangent line. You have to replace the value of y minus y1 equals to m times x minus x1. But instead of putting here the slope of the tangent line, you're going to put the slope of the normal line you already obtained by doing the reciprocal inverse. So let's do it, and this problem is going to be finished. As we remember, it was y minus y1 that was 2. Okay, if you don't remember, I'm going to put here. Okay, that's you can copy it. You should already copy this before. But well, equals to the slope that now is going to be 1/2 times x. X is going to be x minus x1, that it was 1. Now you have to simplify this equation. I'm going to do it right here, and it's going to be y equals 1/2 times x is 1/2 of x. 1/2 minus 1, it's going to be minus 1/2, and this minus 2 is going to pass to the other side with changed sign, so it's going to be +2. Now this you have to simplify it. So the way to simplify this is going to be like this. It's going to be y equals to 1.5x, and the complicated thing here is that you will have to do this subtraction, -1 plus 2. So I'm going to do it separately here in the bottom. -1 plus 2, right? So I'm going to write 2. Well, I'm going to do it in the way we already saw like 10 times during the whole semesters in high school. So there are two ways. I can put it like this: 4/2, because 4/2 it's 2. Or you can do it in the other way, that you have to multiply denominators and then cross. But well, it's the same. So how much is -4 plus 4? You -1 plus 4. It's going to be 3, and the denominators stay the same. That's 3 halves. So the other way, it was -1 half plus 2/1. It's going to be 2 times 1, 2, and then cross. 1 times -1 is -1, and 2 times 2 is 4. So you're going to obtain the same at the end. Okay, 3 halves. So at the end, you are going to obtain 1/2 of x plus 3 halves, and this is the equation of the normal. Okay, and this was the equation of the tangent line. So I think it's pretty easy, but you have to practice like maybe you do 5 or 10 or 20 problems, maybe you'll get it very, very easy. But maybe we're in the next video, or when we see it in by virtual class, we are going to do some exercises of this. Maybe we'll only have time to do 1 or 2, but if you have questions, be sure you ask me in the virtual class. Okay, so well, hope is enough, and hope is clear. Have a good night, guys. Well, good day, I don't know, whatever. See you.